Happy Friday, everyone. Happy 24th of July. I hope you guys are all having a fantastic summer right now. And I'm Elizabeth Cropper. I'm here at the Hill Aerospace Museum. I'm the education specialist here, and we're coming back and doing some more experiments and talking more, giving some more summer STEM lessons today, or another summer STEM lesson today for your passport. Once again, Raylyn and I, our education team here at Hill Aerospace Museum, will be outside in the outdoor air park between 1 and 3 p.m. today, punching passports and passing out passport packets if you haven't gotten yours yet. So please feel free to come get it in person. We will be wearing a mask and being sanitary if you're concerned about that. So we'll be happy to see you. We've been seeing a couple people come and a couple of times and getting their passports punched, and we have been so elated to see you guys. We've really missed you guys this summer, and we hope to be able to open. We don't know when that's going to happen exactly, but we're really excited about you guys, and we miss you. So anyway, getting onto that, if you guys can see this awesome plane behind me, I am sitting in the back of the F-111, known as the Aardvark, and this actually has a really good key into our lesson today, and we'll talk about it in just a second. But a lot of the topics that we're covering in this STEM Summer Passport program touch a lot on what pilots and people in the Air Force have to worry about all the time. So we're going to talk about how it relates to this plane. It's going to be really cool. So if you guys remember from a couple weeks ago, our very first lesson, we talked about energy, right? We talked about potential and kinetic energy and how the potential things have the ability to become kinetic and move and turn into motion, and that we can then take that motion and do other things with it, right? We did that little hydro mechanical energy where we spun the fidget spinner, if you guys will remember that, and we do use that type of motion to take it and create electrical energy. And that is what we're going to talk about today. We're going to talk about electricity and sort of the base things in our world, in our universe, that create electricity. And I want you to think about it for a second. What are some things in your life that require electricity to function? Think about this. You're welcome to post or respond in your living room. What are some things in your life that require electricity? I can feel your brains, like your brainwaves going. We're all thinking about electricity, right? Our phones, our light bulbs, sometimes our ovens, you can name thousands upon thousands of things that require electricity to function, right? Our everyday lives really run a great deal upon electricity. So it's really important to kind of know how that works, right? So I want you guys to think for a second, if you've ever been, I don't know if you've got any bunny slippers or big bear slippers, if you've ever walked across your floor in your house and kind of dragged your feet or dragged your slippers, and then you touch another person and you feel a big zap. Have you ever felt that zap feeling? Did you know that when you zap someone like that, it's electricity, it's electrical energy? That's crazy, right? Or my favorite, I've got this awesome little unicorn bear down here. Have you ever, been in your room at night and the lights are off and you rub the belly of your favorite stuffed animal really fast and you see like little flashes of light go off and on? You see a little spark? That is electricity. It's actually something called static discharge. And we're going to talk for a second about what creates static discharge. So electricity actually functions, it takes the very base or foundation of our entire universe to function, and that is something called the atom. So everything in our world, every single thing is created or made up of atoms. There's these little things, and these are actually what make electricity work, and I'm going to talk about that for a second. So if you guys look at this picture real quick, you can see a couple of different things. So there's these spinny things on the outside, and there's this big thing in the middle, and atoms are made up of 3 parts. In the middle here, we have 2 things. We have these little blue things, and I don't know if they actually look blue. I've never actually been able to look at an atom up close. I don't know if anyone ever really has. You can see them through a microscope, but the microscope itself is made up of atoms, so it's really hard to see the actual atom. But we do know what they are made up of, and we know the general idea of what they look like. So this middle thing in here, it's called the nucleus, and it has 2 parts in it. It has something called a neutron and a proton. And then on the outside, there are these things that are floating around that are called electrons. So what's cool about these things is that each of these different parts, they have something called a charge. So if you guys will remember, we talked about magnets last week and how there's north poles and south poles, negative and positive charges. Atoms are the same way. There are different parts of them that have a different type of charge. They radiate a different type of energy. And these things right here called protons, they have what's known as a positive charge. And these little neutrons right here, they are, you guessed it, neutral. They don't have a charge. They don't have positive or negative. They are simply neutral. And then on the outside, there are these things that are called electrons, and they have a negative charge. So something that's really important about atoms is that atoms, in order to be balanced and have equilibrium, this number here in the middle of protons needs to be the same as the number of electrons on the outside. So if something does not have the same amount of protons and electrons and they're not equal in their amounts, that atom will be slightly dysfunctional, or it won't be acting the right way. It will not be in equilibrium or in balance. And that is actually really important to how electricity works. So you can see these little electrons around here, and they're kind of like flying around, right? And when I see this, I'm literally picturing my shirt. I picture the atoms on my shirt, and I picture that there are things that I cannot see that are flying around, that are around that atom. And these things are actually, it's really, really easy for an atom to lose these little things that fly around. So when you touch something or things move around, when you're wearing your slippers and you're dragging them across the floor, or when I am taking my stuffed animal and I'm rubbing it real quick, I'm actually moving around the electrons on the atom. I'm moving it around. And when I'm doing that, I'm making it so that those electrons, they move out of place. They go to the wrong spot. So if you are walking around your house and you're dragging your feet, you're actually picking up electrons from another spot. You can't see it, you don't know, but you're picking up those electrons. And then you can sometimes, maybe if you touch a doorknob or a metal wall, those electrons, what do they want? Though that atom wants to be equal, right? We have all these parts and they really want to be equal with each other. So when you feel that zap, it is like those electrons suddenly realizing that they can be equal, that they can reach equilibrium. So when you feel that zap, just imagine those electrons going back to an equal state with the other atoms in the area. It's crazy, right? We can't even see this, and it is functioning around us all the time. So you guys can even experiment with this. You can go, start dragging your feet around your house and then touching your mom or touching your dad and zapping them and seeing, what those atoms do and making that zap sound. You definitely have to say zap when you do it, or you'll probably feel it anyway. So, all right, so that's the atom. And when you do that, you're creating a static discharge, right? And so we talked about how these charges, so the proton, the positive charge and the negative charge, they want to be together to create that equilibrium, that balance in the atom. And that also means that when there's a ton of electrons in one spot, they don't like each other. If you guys remember last week when we talked about magnets, we talked about how those, when things are the same, they don't like each other. If you guys remember, we did those little floating magnets and things, we did north and south poles. When things are the same, they don't like each other. They don't want to be touching each other. And when things are opposite, they do want each other. They pull together. Atoms are the exact same way, and those electrons, they do not want to be next to each other. You can pull them, you can drag them, they can be next to each other, but they would rather be in equilibrium with those protons. They're drawn towards the protons. So you can see this. This is actually a little thing. Oh, my balloon fell off. Right here. I've got this little piece of plastic, and I have this little wand. I'll call it an electron wand. So this little wand, it generates electrons along this little end right here. And I'm going to stick my plastic on the end. We'll see. The air pressure is funny in here today, so we'll see how it happens. And I'm going to click my little button and turn it on. Whoa, it flew away. So this is actually generating electrons, and it made that little piece of plastic fly away because the electrons repelled each other. They didn't like each other. So there's another way that you can do this. I've got this machine over here. It's called a Van de Graaff. And I have a friend. Unfortunately, she doesn't have a body today. She's just a head, but her name is Sarah. She's right here, and she is going to sit here on the Van de Graaff. And the Van de Graaff is a machine that collects the electrons in the air and puts them in one place, and discharges them in one place. So she's going to sit here on the Van de Graaff. And I'm gonna try really hard not to get shocked. We'll see how this goes. And one thing that's really important is that she's touching the Van de Graaff. The Van de Graaff is not touching the ground. That's very, very important. It's touching this, but there's like a piece of rubber between the Van de Graaff and the ground so that it's not touching the ground. It's very important. And I'm gonna turn this on and we're gonna see what happens to Sarah and the electrons in her hair. Whoa, can you guys see that? She's got all those electrons and they are repelling each other. They don't like each other. So you can, ooh, I'm gonna get shocked. She is, all the electrons in her hair are repelling. And you can even see if I move my hand up and down, they're getting attracted to the protons in my hand. They're getting attracted, they want equilibrium, right? And we're gonna take this long metal rod and we're going to steal her electrons right over here. Super cool, right? You can steal the electrons with this rod, and this connects her and it connects me to the ground. So she's not touching the ground. Those atoms, those electrons, not the atoms, the electrons want to go somewhere. And when I use this little wand, it's providing a place for them to go. So I'm stealing her electrons and I'm actually reconnecting her to the ground. It's pretty cool. I could do this all day. Just watch her hair go up and down. But because I don't want to get shocked, I'm going to turn it off. Okay. And those electrons are still there. She actually needs to be done, something that needs to be done to her, it's called grounding. So those electrons, when they don't have somewhere to go, they will make that static, they'll make all that, her hair stand up. And if I do something, if I ground her, I'm connected to the ground, I'm touching the ground, right? Those electrons want to go somewhere, and the fastest and easiest place for them to touch is the earth. That's the place where they can reach equilibrium the fastest. So I'm going to touch her, and I'm going to bring her back down to equilibrium over here. I'm going to ground her hair with this little grounding wand. So she has gone back to equilibrium. Sarah's hair and her head is okay. That's very important. I did try to do that with my own hair earlier today, but I have too much product in it, and so my hair did not want to stand up. So we tried it with Sarah instead. So this is really interesting when you touch the ground. So do any of you guys know that lightning is a type of static discharge? This is happening in the air all the time. When we get storms, those electrons, they're constantly moving around, right, with airflow and up in the clouds. There is, those electrons are constantly moving around and they need equilibrium. So they create a static discharge, and that discharge wants to reach the ground because that is the fastest place for those atoms to become equal, for those electrons to reach equilibrium and to be dispersed among atoms in the right way once again. So this is a very, very important concept, especially for pilots and people who work with planes. So right behind me, you can see this F-111, the aardvark, and you can't see it very well, but I think if you look right about where my hand is and I go back, there are these little things on the plane, and you can actually see, I've got one right here that's an old used one from a plane called static dischargers. So those planes, they're flying through the air very, very fast. And they are disturbing the atoms in the air, right? So they're disturbing atoms in the air because they're making it move really fast. The air is moving really fast. And that means that those planes are also picking up electrons. Those electrons want to reach, they want equilibrium, right? They want to be restored back to that equal place with those protons in atoms. And so it creates a static discharge. And on planes, it's very important that we have these little things on the back of the plane. And that's why we're at the back of the plane, not the front of the plane. There are these little things on the very back of the wings called static dischargers that make it so that we don't get electrocuted while we're in planes. And I don't know that we would be electrocuted inside, but we don't want the plane to get harmed by all that static electricity. It's very, very important. So this is a static discharger, and if you look on the back of planes, not all of the planes here have them, but when we open up again in a little while, whenever that happens, you can come in and you can see and look for those little static dischargers on those planes. They're very, very important. Another thing that we have to do with our planes is do something called using a grounding wire. This is a grounding wire from a plane. Not any particular plane, it doesn't have to be only to one plane, but all of those planes usually have a little plug-in on the side where you can stick this in and you can ground them. So that's if they are, at the airport and they're not being used and there's a storm outside and they get struck by lightning, they need to be grounded to the ground so that lightning has a place to go and it does not harm the plane. It's very important. So the same way that we used, whoops, my balloons are falling all over the place. The same way that we used this wand to ground Sarah's hair to give those electrons a place to go, we have to use grounding wires in a much bigger scale on airplanes to make sure that those electrons have a place to go so they get grounded, right? Because we do not want to have any sort of accidents or anything like that to anyone that we care about. And we care about everyone, so. All right, so you're gonna do something really cool if you wanna join. There is actually a way to help if you want to do it, you can do it. You can ask your parents if you can do it to their hair. I like doing it to my hair because my hair is a little long, but I will tell you, I'm doing this. It is a sacrifice. I do not like static. I really don't like staticky hair. From day one, when we used the Graaff here, when I started working here, I really, really don't like getting static in my hair. So I'm gonna put some static in my hair for you guys because I love you guys and I really care about you. But we're gonna do a little bit of an experiment. You're gonna take a balloon and you can blow it up whatever size you want. I like it when they're big, and orange is my favorite color. So I'm gonna do an orange balloon. And I'm gonna take it and I'm gonna go with my hair, and hopefully you guys can see this. And I'm gonna go like this, and I'm rubbing this balloon around. And I'm actually picking up electrons from my hair. Now, when I'm all done, I'm going to keep getting more of it in my hair. And I'm rubbing these, and I'm getting electrons that are attracted to the balloon. Now, when I take it away, look what happens to my hair. Do you see that? Yeah? What's happening to my hair? Is it getting attracted to the balloon? Yeah? Is that saying I'm attractive? Just kidding. So the electrons in my hair that are getting pulled away by the balloon, my hair still wants those electrons. So it's getting pulled by the balloon. It is attracted to the balloon because it needs those electrons. It wants that equilibrium. So if you want, once you're done with that, now that I've taken all these electrons out of my hair, and it's not sticking in one place, it's kind of just floating around everywhere. You can also take, a grounding and try to ground yourself and see if it works. I don't know if it will really work super well because it's not the same type of, you're actually pulling electrons from your hair and not putting them in. But I don't like static, so I'm gonna try it anyway. So you guys can try this at home, take this balloon and try to create, the opposites attract with someone's hair. And you can even try, to create your own static discharge by kind of rolling your feet around and seeing what happens, and then trying to pull electrons from your hair and then making them attract to the balloon because it needs those electrons. It wants equilibrium. So, and just in science, as far as generating electricity goes, the last thing I'll say is that in order to do that, we take motion, and we can actually funnel kind of that motion and those electrons and that electrical energy into cords, into power lines that then are able to be used all over in our lives and in our houses. So, all right, that is our lesson for this week. I hope you guys enjoyed it. I really enjoyed, getting static in my hair for you guys. We'll see you guys soon, and hopefully let us know if you guys have any questions or comments. Please feel free to go ahead and post any pictures of you or your kids doing these experiments. We love hearing from you guys. You guys have done a great job, and we miss you, and have a fantastic Friday.